Let us start with question number 18. Impure copper containing iron, gold, silver as impurities is electrolytically refined. A current of 140 ampere. So I is equal to 140 ampere for 482.5 seconds. So time is equal to 482.5 seconds. Decreased the mass of anode by 22.626 grams. So decreased the mass of anode. So decreased the mass of anode by 22.26 grams and increased the mass of cathode. So increased the mass of cathode by 22.011 grams. Percentage of iron in impure copper is given that molar mass of iron. So they have given that molar mass of iron is 55.5 gram per mole and the molar mass of copper is 63.54 gram per mole. So from the equation, from the given data itself, they have given that mass of anode is decreased by 22.26 and mass of cathode is increased by 22.011. Therefore, from this I can calculate what the impurity present. So the impurity present is equal to how much? Increase in the mass by decrease in the mass of anode by 22.26 minus increase in the mass of cathode by 22.011. So it comes out to be 0.249 grams, which is nothing but the impurity present. So it has been given that current of 140 ampere is passed for a time duration of 482.5 seconds. We know that Q is equal to I into T, that is nothing but current into time. So current is 140 amperes, time is 482.5 seconds, which comes out to be 67,550 coulombs of electric current or electricity is passed through it. So it has been given that mass of copper is 63.54 and the mass of iron is 55.5. Now let us do the equivalent weight of copper, because for Z I should know the equivalent weight. Then I will calculate the equivalent weight of copper is equal to 63.54 divided by 2, because the valency of copper is plus 2, which comes out to be 31.77. So I can analyze it by the equation. So copper ion gains 2 electrons, which gives rise to copper according to this respective equation. Therefore, I can calculate the mass of copper. So therefore, the mass of copper that should be deposited, or the mass of copper deposited, is equal to 67,550 coulombs of electricity divided by 1 farad, that is 96,500, into equivalent mass is how much? 31.77. So by this I can calculate it as how much? 22.239 grams is the mass of copper deposited. So here it has been given that increase in the mass of cathode. So from the data it is given that increase in mass of cathode is 22.011 grams. So from this I can analyze that 22.239 grams of copper is deposited minus increase in the mass of cathode is how much? 22.011. So that is equal to 0.228 grams corresponds to mass of copper. So therefore corresponds to the mass of copper which is not deposited, corresponds to the mass of copper which is not deposited. Therefore it can be equated to the mass of iron. That is passed in solution. Therefore by this I can clearly calculate the equivalent mass of iron is equal to 55.5 divided by 2, that is equal to 27.75, which can be analyzed by the equation Fe plus 2, which gains 2 electrons, that will give rise to Fe. Therefore, the mass of iron is equal to 0.228. So that has been obtained here, 0.228 into 27.75, which is 0.199 grams. So when I calculate the percentage of iron for this, therefore the percentage of iron is equal to mass of iron. Mass of iron is how much? Percentage of iron is equal to, I'll write it as mass of iron divided by mass of impurities divided by mass of impurities at anode into 100. So mass of iron is how much? That is 0.199 divided by mass of the impurities at anode is how much? That is 22.26 is the mass of the impurities at anode into 100. So which comes out to be how much? 90%. So if I write it in terms of fraction, it will be 0.90. Hence, it will be 0.90. Hence, the correct option for question number 18 is option D, which is given as 0.90.